Hi folks, we're moving on with the series and sequence unit. We're moving on to geometric series, and again, if you're watching this video, that means that I'm not here unexpectedly. It's okay that you have, that if you just jump in at this lesson, if you haven't seen any of the other ones. I'll talk briefly about what we did in the past lessons, but this is the fourth lesson of this chapter. Again, these are pretty standalone lessons, so they don't really build on each other. They are related, so it definitely doesn't hurt to have done them, but it won't hurt you not to have done them. Okay, so today we're talking about geometric series. So if you're looking on your formula sheet, it's near the bottom, and the geometric series is right here, and it has two options. Okay, just like if you're looking at the arithmetic series, it has two options. This one also has two options. So we're going to write those down on our notes. Okay, so let's talk just quickly about what geometric means. So when we're in this unit, we're talking about patterns in number sets. And so a geometric series does something very specific. Geometric means you multiply to get to your next number. Okay, so that's important. And arithmetic, you're going to add. So series is the way we take the sum. So the sum of a set of terms in a pattern. Okay, so when we're talking about series, the whole point of series is a formula that's going to do the adding for you, instead of you sitting there with your calculator and adding the first 100 terms of the sequence. So keep in mind that a series is just a quick way, a formula to calculate the sum. So instead, like I said, instead of using your calculator to add, we're going to use the formula and it would do the same thing. Less likely to make a transcription error using the formula than it would be to go like 1 plus 2 plus 3 plus 4 all the way to 100 or whatever. So that's important, the multiply. Also, just want to point out that let's say my series is 8, 4, 2, 1, 1/2, and it continues on. Now you're like, okay, Scallion, I'm not multiplying to get to the next number. I'm dividing by 2, essentially is what I'm doing. But we can change dividing by 2 into a multiplication. So in words, we're saying we divide by 2 to get to the next number, which is the exact same thing as saying we are multiplying by 1/2. So we're still doing the exact same thing. We still get the exact same result. 8 times 1/2 gives me 4. 4 times 1/2 gives me 2. So remember, we're always doing this in the context of multiplying. Okay, so geometric series, you have two options. So our first one is Sn equals T1 times r to the exponent n, subtract 1 over r minus 1. Now there's a restriction after it, and the restriction just says that r cannot equal 1. And the reason why is because if I substitute 1 in here, 1 minus 1 is 0, and we know that you can never divide by 0. You'll get an error, the world will collapse in on itself. So it's just saying, hey, this is the restriction. R can be anything but 1. It can be a decimal, it could be a whole number, it could be big, it could be small, but it just can't be 1. So that's your restriction. And then your other option is Sn is equal to r times Tn minus T1 all over r minus 1 with the exact same restriction. So when you see a comma, everything after that isn't included in the calculations. This is just where it says, oh, and by the way, when you calculate something, your answer can't be, your r, your variable r, cannot be 1. So again, this is my restriction. So commas tell us what's coming next. So this is not included in your formula. Okay. Okay, so let's define some variables. Sn, this is the sum, hence the letter S, of n terms. So it's just saying, hey, I'm summing, and if your number's 10, then the n would be 10. Let's jump right into n. N is the number of terms. R is your, what we call the common ratio. And the common ratio is what you're multiplying to get to that next number. So the common ratio in this isn't 2, it's 1/2, because we always do it in the frame of multiplying. So the common ratio for this one is 1/2. So it's what you multiply by to get to your next term. T1 is the value of the first term. And Tn is the value of the last term. Okay, so let's be really specific. If you're trying to find what the value of the 10th term is, you need a sequence formula. So you would need the geometric sequence formula. Okay, so if I'm trying to find out what the term is, how much that's worth, then that's a T formula. Because these are going to tell me what the sum is. So it's going to add up the first 10 terms for me, or the first 20 terms, or whatever we want. Okay, so let's jump into the examples. I think the big thing with this unit is, again, I'll say it every time I start a video, is order of operations, paying attention to the formulas, because they're all super close. Like, so make sure you know and copy down your formula correctly. Order of operations and paying attention to your formula. Okay, so this says determine the sum of the first 8 terms. Okay, so I know I'm following the sum, so I know that I need a series here. And I know my n is 8, because it says for the first 3 terms. And it's telling me it's geometric. All right, so I know my T1 is 5. The value of my first term is 5. I know my n is 8. And then I guess the next question is the common ratio. How do I get from here to here? What mathematical operation do I do? It's saying geometric, so I know I have to multiply by something. So I think most of us can figure out that we're timesing by 3 to get to our terms. Now, like I said in other lessons, sometimes this isn't obvious. So the way to figure out your common ratio is to take, let's say, T2 and divide it by T1. You always take this term and divide by the term in front of it. You get the exact same answer no matter where you are in this. I could take 45 and divide it by 15. I'll still get 3. So the only reason why I tell you this is like, you're like, Scallion, this is obvious. This is obvious when it's easy, when it's whole numbers, but if it's fractions, sometimes it doesn't pop off the page to you. So if you need to learn how to calculate that, then do it this way. Okay, here's the thing, ladies and gentlemen. We don't know what Tn is. This just tells us using the ellipses that it goes on forever. So I'm just going to hop to my formula sheet for a second. So in this one, I'm trying to find the sum. I have T1, I have the ratio, I have n. I'm going to have to use this first option here because I don't know Tn. And this second option needs Tn to work. So I have to use option 1. So I'm going to have Sn is equal to T1 times r to the exponent n, then subtract 1, all divided by r minus 1. Okay, so that's the formula. It's a little bit different than the sequence formula. The minus 1 was in the exponent. This one, it's not. So I'm trying to find S8. T1 is 5. R is 3. 8 minus 1 all over 3 minus 1. So I'm going to keep moving on over here. Haven't left a ton of room for this. So I'm finding, and I just put the 8 in here because that reminds me that I'm summing the first 8 terms. So I have 5. 3 to the exponent 8. I'm sure you're all shouting the answer at me. Sorry if you can't. That's kind of right in the way. 3 to the exponent 8 is 6,561. Subtract 1 divided by 2. Now, order of operations says I got to deal with this exponent first, and then I got to do what's in the brackets, and then I multiply by 5. So I'm going to show you all the steps, but again, you don't have to, if you want to skip some steps, that's okay too. I'm okay with that. So I'm going to minus 1 times by 5. So S8 gives me 32,800 divided by 2. So the sum of the first 8 terms is 16,400. No units of measure on this because we don't know what these numbers represent. Oh, sorry guys, you can't see that. So no units of measure, it's just taking these random numbers that are connected with a pattern, and we're just summing the first 8 terms. And when I talk about transcription errors, if you were to add this up in your calculator, first of all, you'd have to figure out what the first 8 terms were, and then you'd add those 8 terms together. And you get the exact same answer. So if all else fails, you can do that. But again, that can become very tedious when I'm looking for larger numbers to be summed together. This one's nice because it figured it all out for us, and we just know from the question that n is equal to 8. So again, I don't have Tn, I don't have the last term, so I got to stick with that first formula, so I'm sticking with this. I'm not going to rewrite it because it's right there. So we're summing the first 8 terms. 64, I have 1/4 to the exponent 8 minus 1. And again, I put the 1/4 has to be in brackets because the exponent 8 applies to both the numerator and the denominator. So make sure that you do that. And then I have 1/4 minus 1. And all of a sudden you're freaking out because they're fractions. It's really no big deal. So S8 equals 64. Now, a lot of you might be tempted to go to decimals, and that's okay to do that. But again, I think you do need practice in using fractions. And so I'm going to do 1 to the exponent 8 is 1, and 4 to the exponent 8 is 65,536. Holy Hannah, this is a lot. I'm going to minus 1 from that. And down here, I'm going to have 1/4 minus 4/4. Because we know when we're adding or subtracting exponents, adding or subtracting fractions, that we need common denominators. Okay, so same deal here. I should probably make this a common denominator. I'm just going to hop up here for a second. So S8 is equal to 64 times 1 over 65,536 minus 65,536 over 65,536 all over, I'm going to subtract this, so negative 3/4. Holy Hannah, that's a lot of, these are some big fractions. So this is going to be negative 65,535 over 65,536 divided by negative 3/4. Oh my goodness, that's intense. Those are some big numbers, but it's not that big of a deal. We know that how we multiply fractions is like saying 64 over 1. So straight across the top, straight across the bottom. So my numerator is going to be S8. I need to keep those equal signs in there, so don't lose your equal signs. 4,194,240. But this is a positive, this is a negative, so this should be negative all over 65,536. You guys are like, can I go to decimals, please? And I guess you could. You totally could. I'm showing you as fractions. It's nothing, like, as long as you're true and follow your math rules, you're not going to run into any problems, even though the numbers are really big. So we're dividing by a fraction. And I'm going to just hop to, we don't divide by fractions, we multiply by the reciprocals. Is everybody okay with that? Okay. All right. I wonder if these go into each other evenly. Probably not because of a 6 and a 0, but I just want to check. I want to check to see if this divides evenly. 4, 1, 9, 4, 2, 4, 0, divided by 65, 5, 3, 6. Nope, doesn't go in evenly. Really, really close, almost 64. All right, so let's multiply through. So I have 4,194,240 times by 4. So, sorry, I'm just switching up here. S8 is equal to 16,776,960. And that's a negative because this is a negative and that's a positive. And then I've got 65,536 times 3. That gives me 196,608. Now, that's also a negative. If you have a negative, sorry guys, I'm right off the page. If you have a negative on the top and a negative on the bottom, we know that they're both positive. I'm going to stop there. It's a nice thing about fractions is I can stop there. I probably could reduce it, but I'm not going to spend time reducing it. So that was an ugly one. But don't be afraid of big numbers or fractions in it. You guys would be fine. Whew. All right, that was a lot of mathin'. All right, okay. So I'm looking at example number 2. It says determine the sum of the geometric sequence. All right, so I know my T1, this is my T1, and I know my Tn. So that's a positive thing. What I don't know if this is leaping off the page at you, is that I don't know what my n value is. And so I'm a little nervous about that because it doesn't tell me what my n value is. But the cool thing is that if I look at my second formula here, nowhere in here does it say any of these variables need to be n. Yes, there's a little tiny n right there, but that just means your last term. We know the value of our last term. So I don't even actually have to calculate n, which is less math for me to do. So I don't know how many terms there are, but it's not really important. So Sn equals r times Tn minus T1 all over r minus 1. Note, I'm not writing the restriction. I don't have to, but I do have to pay attention to it if I were calculating r. In this case, I know what r is. Do we know what r is? So r, I'm not sure if it pops off the page at you yet. So what I'm going to do is I'm going to take the second term, 1/16, and I'm going to divide it by the first term, 1/64. So r is equal to 1/16 times by the reciprocal. So 64 over 16. And if I do that math, that should give me 4. So my r is 4. So I know my r, that goes here and here. I know my Tn, that's 1024. And I know my T1, which is 1/64. Easy peasy. Now we just substitute that in. Sn, so 4 times 1024 minus 1/64 all over 4 minus 1. So Sn equals, so again, order of operations matter. I'm going to do my multiplying first. How do you guys feel about going to decimals on this one? Just to make it a little bit easier since you suffered through. So if I change that into a decimal, that is 0.000 0.015625. And all I did in my calculator was take 1 and divide it by 64. So SN 4096 minus this decimal is going to give me 4095.984375. Hey, Miss Gallion, can we round? The answer is no. You only round in your answer. Negative. Ooh, sorry, that shouldn't be a negative. That should be a positive. 1,365.328125. And that's the sum of your terms. I don't know how many there are, but summing from this term to that term, if I add them all up, and see, we couldn't, I guess we could do this, but then again, that would be tedious. You'd have to know every term, you'd have to calculate it. And I don't know how many numbers there are. I don't know if there's 100 or I don't know if there's 10. So by using the formulas, you kind of get rid of that altogether. All right, here we go. Word problems. It's just about extracting the information from them that you need. Okay, so Scrabble Tournament of Champions has a format that each loser of the game of Scrabble is eliminated from the tournament. The winner continues on to the next round of play. If there are 256 entries, so 256 people, what will be the total number of games played? So total number tells me right away that I'm summing. Because it wants to know not how many games will I play the first round, how many games will I play the third round. It just wants to know all together, if you're the winner, how many games did you actually play? No, that's not true. How many games were played in the actual tournament? Okay, so we know a couple of things. We know if there's 256 people, how many games are there? So 2 people to play 1 game. So the very first round of play is going to be, so my T1 is going to be my 256 divided in half, which gives me 128. Because I don't, if we said 256 was my first number, that would mean everybody's playing by themselves. And that means everybody's a winner, which means nobody loses, which means nobody's eliminated. All right, so TN, in the final round, in the last round of play, how many games are being played? It's for all the marbles. This is not the NHL. We don't play it 7 times to figure out who's the winner. We play it once. This is cutthroat Scrabble rules. So in the end, you're going to have 1 game. And once that game's finished, you would declare who was the overall Tournament of Champions. All right, so what do you notice about the numbers? We start at 128 and we go all the way to 1. The numbers are being reduced each time, right? So we know that after 128 games, we know that half of those people will be eliminated. So 128 is my first term, so that's term 1. Term 2, if it's half of this, if it's half of that, then we're going to be at 64. And then half of these people lose, because there's always a loser. And so the T3 is going to be 32. So what do you notice? We are halving the number each time. So you might say, hey, Scallion, we're dividing by 2. But remember, we always have to talk in terms of multiplication. So what are we doing to get from here to here? We are timesing by a half. We're not dividing by 2, we're timesing by a half. So my common ratio is 1/2. The nice thing about this one is if I know my T1 and my Tn, I can use that second formula. I don't need to know how many games are played or how many terms there are, how many rounds of the tournament. I don't care. Okay, so let's fill that in. So Sn, because again, I don't know how many we're playing, R times Tn minus T1 over R minus 1. So Sn equals R, which was 1/2, times Tn, which is 1, minus T1, which was 128 games, over 1/2 minus 1. All right, Sn equals 1/2 times 1. That's not supposed to be a 3. That's just, I got excited. 1/2 times 1 is 1/2 minus 128, brain's not working, divide by negative 1/2. So Sn is going to be, oh, you guys are going to love me. We'll just jump to decimals. So it's going to be a negative 127 divided by a negative 1/2. This should make you feel good because as soon as you see two negatives, you know that things are going to work themselves out. So we know that Sn is equal to negative 127.5 times by the reciprocal of that, so times by negative 2 over 1. So Sn, so 127.5 times 2 gives me 255 games. So in total, in the tournament, 255 games were played. That's pretty good. So that's the end of that lesson. You guys have the assignment to go with it. If you have any questions, let me know. Send me emails. I'll do my best to get back to you. Thanks and have a good day. That's stuff I have to do.